Homework 3.1, Quadratic Functions, Video 6. Homework due 11:59 p.m. on Wednesday, May 27th, 2020. The following video correlates to homework questions 9, 10, 11, 12, and 13. Maxima and minima. Now those are words you may not be familiar with. You might think Maxima is just a model car. But as nouns, a maximum is a high point on a graph and a minimum is a low point on a graph. But as nouns, maximum and minimum are singular. Maxima and minima are plural. If you are on the calculus path, you will run across the words maxima and minima quite a bit, but the grammar side of me couldn't just put the incorrect words up there. So again, maxima as a noun is the plural of maximum, and minima as a noun is the plural of minimum, like bacteria is the plural of bacterium. Didn't know that? Now you know. So these questions involve the vertex, but from the perspective of being the highest or lowest point on a graph. And in the two videos that conclude this series after this one, we're going to be using the idea of a high or a low point to solve some what are called optimization problems, how to maximize a value or how to minimize a value. So for example, let's consider the function f of x equals 3x squared minus 6x plus 4. Part A, does this have a maximum value or minimum value? That's pretty easy to answer. We'll do it in a moment. Part B, find the max/min value, whichever one it is, and where it occurs. This is actually pretty easy to do. The hardest part about it is the semantics. And then give the domain and range. All right, so let's start with part A. Does it have a maximum or a minimum value? The answer to whether it has a maximum or minimum value is contingent on whether the parabola opens up or opens down. Specifically, if your parabola opens up, then it has a minimum value, and if your parabola opens down, then it has a maximum value. But how can we predict that? Based on whether the leading coefficient is positive or negative. A positive leading coefficient means there's a minimum, and a negative leading coefficient means there's a maximum. That sounds a little bit backwards. What do you mean positive is minimum and negative is maximum? Well, positive opens up, so there's a lowest point. Negative opens down, so there's a highest point. So we can answer the which one it has without doing any work and just observing the fact that 3 is positive. So since 3 is greater than 0, what does that mean? Is there a maximum or a minimum value? Parabola opens up, so there's a minimum value at the bottom of it. So we know the parabola is going to look like this. Now for part B, when they say find the maximum value and where it occurs, as adjectives, the words maximum and minimum are referring to the y values on the graph. At the lowest point, you have a minimum y value. At the highest point, you have a maximum y value. So when it asks you what's the max or min value, it's asking you for a y value. And this is where I said semantics are an issue. The max or min value is the y coordinate of the vertex. The x coordinate is where it occurs. Do you remember when we were first figuring out how to locate the vertex by averaging the x-intercepts? When we averaged them, we said that's where it is. We just don't know what it is. We know it's at x equals 3. We don't know how far up or down it goes. So what is the y-coordinate and where is the x-coordinate? Well, we can't answer either until we find the vertex. So let's find the vertex, starting with the x-coordinate. Now this function is in general form, and more generically it looks like this. So to find the x-coordinate of the vertex, we have to calculate negative b over 2a. Not too bad. Negative b over 2a. So let me set this up with parentheses instead of b and a, and then I can just substitute the values. The b is the coefficient of the x, so it's negative 6. The a is the coefficient of x squared, so it's 3. We have -6 on top and 2 times 3 on bottom. So 6 over 6 is equal to 1. So now we know the answer to where. At x equals 1 is where this low value will occur. As far as what is that low value, we just have to put 1 into the function. So 3 times 1 squared minus 6 times 1 plus 4. Be careful here, this is not 9. Don't do 3 times 1 first. You know exponents precede multiplication. 1 squared is 1, then 3 times 1 is 3. 6 times 1 is 6. And if we do all that, I believe we get 1. Well shoot, I didn't want it to be 1 because I didn't want these to be the same. So if you'll allow me to barely tweak the problem, I'm going to change the 4 to a 14. Doesn't change anything that's happened so far, except the very end. And that'll make the sum 11. Again, the only reason I made the quick change from 4 to 14 is because I don't want the x and the y coordinates to be the same, so that I can emphasize the semantics issue behind it. So the answer to question B is at x equals 1, the minimum value is y equals 11. If they were both 1, it would be trickier to remember which is which. All right, so this parabola's lowest point is at 1, 11. So this point is at 1, 11, and from that I can answer part C, which is to give the domain and range. Let's face it, we should have known the domain at the beginning. Go back and watch the first video in section homework 2.6 about domains and functions. No denominators, no radicals, no exclusions. I can substitute any value I want for x, so the domain is all real numbers from -infinity to infinity. But because this parabola opens up, the range does not go down forever. The range starts at the lowest y value, which was 11. Didn't even need the graph of that. I set it right there. It goes up forever to infinity. So these questions are all about interpreting the vertex in the context of being a highest or lowest point. Just remember, it's all about the vertex. And from a semantics issue, the x-coordinate is where the minimum or maximum value occurs, and the y-coordinate is what that minimum or maximum value is. In the next 2 videos, which will wrap up this series, we're going to use the vertex as a maximum or minimum to try to solve some problems.